Hello everyone, and welcome back to another video, and today we're taking a look at a Radeon HD 6850. So why this card specifically? Well, the 6850 is the card that was chosen by HwBot to be the next Cheapaz Chips card. So there's going to be a Cheapaz Chips AMD competition soon, and the 6850 is the card that everyone's gonna be working with. So just like last time, when we had two Cheapaz chips, one on only NVIDIA cards with the GT218 core, and then later only ATI cards with the RV710 core, we this time only work with 6850s. That's because there are cards that use the same core but have different core counts and memory topologies and all that. So we really just say 6850 and only the normal version of the 6850. There is a 1440 core variant of it. That one's not allowed. You need to have the regular 960 core variant. But yeah, so I ordered one. It has arrived well before the comp is gonna even start. I think there's about 2 weeks, maybe even more left until the comp starts, and I already have my card, and as you can see, it's already fairly heavily modded. So yeah, so while I'm gonna take the cooler off to show you the PCB, let's ramble a bit more about the competition. So if you don't know what HwBot Cheapaz Chips is, well, it's a competition that happens every year. Usually there's 2 rounds of it. We already had the GTX 260 comp this year, so there might only be one Cheapaz comp since the 260 comp was kind of like a Cheapaz comp already. But, you know, there's usually multiple rounds a year of these Cheapaz Chips comps, where the idea basically is we take a piece of hardware that doesn't really have a whole lot of submissions for on HwBot, and that is also cheap and easy to get, and we will just make a competition centered around that piece of hardware. Now for the last couple times that has been graphics cards, but people have been throwing around the idea of doing a CPU Cheapaz comp as well. So that might be the next round, but at this point we are still doing a graphics card competition on these here HD 6850s. And I very much approve of the choice of the card here, because the last 2 Cheapaz chips that I've been part of were on very, very low-end cards with 128-bit memory bus that were using DDR2 or DDR3 chips, not proper GDDR, very small cores with mounting spacing that's basically compatible with nothing, VRMs and generally just PCBs that are not really moddable. Yeah, you can throw some capacitors on them, but these PCBs are so basic and so small, you can't really do much with them. So I like the idea of going with something more high-end. The 6850 was a mid-range card when it came out, so you get a PCB like this. So instead of getting a single-phase Vcore, you get a 3-phase Vcore with, you know, there's 4-phase cards too. You can see there was an option for a 4th phase on my card, like my Sapphire card right here, that they didn't go with, and you know, pretty basic memory and VDDCI VRM. But the PCBs on these are much better. There's actually space on the PCB for you to mod things, and the VRMs are actually complex enough so that some mods can even be done. So something like switching, well, actually you can usually also mod switching frequency on the very basic VRMs, but on these you should be able to adjust your load line. Some of the controllers might even have I2C and stuff like that. So we're working with a bit more complex PCBs this time. Not really any more expensive PCBs. These cards can still be had for around 15 euros, at least here in Germany. So it is cheap for what I think. 15 euros, that's like a trip to McDonald's worth. So it can't really go any cheaper than that, realistically. There's a sort of lower limit for what a used piece of hardware can cost before people just don't bother with selling it and just throw them away, and that's around 15 to 10 euros. And yeah, so this is my card. There is not really anything special about why I chose this one specifically. I literally went on eBay, searched HD6850, sorted by price, and bought the very first one. And that ended up being the Sapphire card right here, which honestly, I do not recommend. There is one very big glaring issue with this PCB that I think people should avoid this card. It's not as big of an issue as I originally thought, but it is a pretty big issue. Now, the issue is right over here, and that issue is our Vcore PWM controller. Now, it's got flux on it, so you can't read the model number, but this is an NCP5395T. We have worked with NCP 5000 series controllers before, and they are all a massive pain because they have an overvoltage protection that kicks in very quickly. But because this controller is using the AMD vid mode, since it's on an AMD card, it actually doesn't have as aggressive of an overvoltage protection as it would it be running in NVIDIA mode or Intel mode. Because in NVIDIA or Intel mode, it only allows 100 millivolts of overvoltage above the set vid voltage before this thing shuts down. In AMD mode, it allows, I think, 287 millivolts specifically, is what the datasheet says. I'm not too sure. But yeah, usually if you have an NCP 5000 series controller, you run into the issue of you do your feedback mod and you increase your voltage, and then very soon, like not very high above stock, at a pretty low voltage, they just shut down because you've reached the overvoltage protection threshold. However, since this is using the AMD vid mode and it has the expanded overvoltage protection thing, this seems to be mostly fine. I've had it up to 1.4 volts and it did not shut down. So at least for air and water cooling, you should be okay if you just do a regular feedback mod on this. But if you want more than 1.4 volts, I have not tested that yet because so far I've only been using the stock heatsink, and I don't think running more than 1.4 volts with that would be wise. So I don't exactly know where it stops. The default vid, the boot up vid on this controller is 1.1 volts. So judging by the datasheet, it should shut down at 1.387 volts. It did not. So the vid is actively being changed by the GPU as the card runs to a level that I am not sure about. Maybe it's... Well, the card normally runs at 1.15 volts, but I am not sure what the actual vid on the controller is. Though if you assume 1.15 volts plus 287, that is actually slightly above 1.4 volts, so it might be very close to 1.4 where you do run into overvoltage protection issues. And the only way to fix this overvoltage protection issue on these NCP 5000 series controllers is to either do a vid mod or e-power the card. Now, since Cheapaz Chips is somewhat intended for beginners, now you don't have to be a beginner, you can be an experienced overclocker as well and compete in that, but because it is meant to be cheap and have a low barrier of entry, it's of course meant to be attractive to beginners. What beginners should probably not do is attempt an e-power. So really the only thing left for a beginner to do is a vid mod, and I've tried vid modding this. It shuts down. So that might be a quirk of this specific PCB, but again, this specific PCB is also, as far as I know, the only one where you get this controller, because I know the PCB that Power Color uses, which should be the regular reference PCB, at least for the 3-phase version. There's also a 4-phase reference version when the VRM is on this side. I don't know about that one. But the other PCBs I've seen use a UPI controller, not a non-semiconductor one. Those don't have the OVP issues. But anyway, it's a bit covered by my voltmod cable right here. There. But basically, the problem is this. You have this resistor right here. That resistor is, you can kind of see the traces, connected to 2 of the vid pins. All the other vid pins immediately go into a via into the PCB. So, yeah. So well, I'm pretty sure that all the bit pins that go directly into the PCB are set to 0 by default, because they are probably just going straight to the GPIO pins, which when the PC, like when the card starts up, don't do anything, so those vid pins are set to 0. Then the two pins that it does contact, which I think are vid 1 and vid 4. So it goes from 0 to 5. So I'm pretty sure it's vid 1 and 4 that are not directly going into the PCB. They're actually connected through this resistor to VTT. And if you connect these pins to VTT through that resistor, which is I think a 1 kilo ohm resistor, you set those pins to a logic 1. And the code 010010 should translate into 1.1 volts, which is the startup voltage for this controller. Now, if you look into the datasheet, it will tell you if you set all pins to 0, that gives you 1.55 volts instead of 1.1. And if you only set one of those to 1, you either get 1.15 or 1.5 volts. Now, I wanted to just set 1.55 volts and then just use a volt mod to adjust the voltage downwards, because I don't really think you ever really need more than 1.55 volts. Even when you're sub-zero, you rarely go above that. So I wanted to just set the VID to 1.55 and then have like a potentiometer that just adjusts the voltage downwards so that it doesn't degrade on ambient cooling. However, once I remove that one resistor, which has both of the pins that you can set to 0 going through it, the VRM no longer starts up. I don't know why. According to the datasheet, it should just start up at 1.55 volts. It does not, and that's the point where I gave up on it. Now, I have been told by someone that the theory is that maybe at least one of them needs to set to be to a 1. If all of them are set to 0, the thing maybe goes into a failure state. But for that to happen, because both of the pins go through one resistor, I can't just remove the resistor that sets both of them to 0. I would have to cut the trace to one of the pins. And I'm just like, if that doesn't work, then I have a cut trace on my controller and a card that doesn't work. So I'm not doing that, which is sad, because you can't really vid mod this. Now, it might work if you cut the trace. I'm not gonna try it. 1.4 volts I think is gonna be enough, and I do plan to e-power this card anyway, so I should be fine. But I just wanted to mention that for anyone who might try to compete in this comp and will buy one of these Sapphire free-phase PCBs, because they are very common. At least in Germany, these are like 80% of all 6850s are this specific PCB. You should avoid it if you can. So, yeah. And that's the main issue with this PCB. There's not really any other issues with this. Everything else is just kind of fine. Like, it's not particularly amazing. You know, yeah, there could have been a fourth phase, but honestly, I don't think the card needs it. It draws very little power. I had my PMD connected, and while I was doing testing, it only drew 26 watts from the 6-pin. And it's only gonna be drawing up to 75 watts from the PCI Express slot. I don't think it even needs a 3-phase Vcore. Like, Nvidia has a card, like the GTX 650 has a similar amount of power draw, and that one has a 2-phase that doesn't even have a heatsink on it. So honestly, this VRM is probably overkill. And given the oscilloscope shots I took of this card, yeah, it probably actually is, at least compared to what Nvidia would put on a card like this. Because voltage regulation on this is actually pretty good. Like, it's not amazing, because the card's not modded yet. Like, I mean, it is modded, but not in any way that's gonna affect voltage regulation. This is just for voltage control and measurement. But I'm surprised how good voltage regulation on this already is, even though this is even one of the cheaper 6850 PCBs. If I could have gotten a Toxic, I would have gotten the Toxic, but there was none available. There was only one single card that was not a 3-phase PCB. That one was a 2 gig, and it cost 3 times as much as this card. And I was just like, no. So, yeah. But speaking of 2 gig, it is of course always a factor with GPU overclocking, you want to have a specific VRAM IC, and I rolled Elpida, as you can see. Now, Elpida is said to be the worst. These are not good. Elpida memory is pretty much always garbage when it shows up, but it might not be too big of a problem, actually. Now, general wisdom for these cards seems to be that you want Hynix chips. That's what I've been told. So these use 1 gigabit GDDR5. I've worked quite a bit with 1 gigabit GDDR5, and I found the Samsung chips to be the best, but it seems that Samsung chips on these are just not available, in which case, yeah, I could see how you might want to have Hynix, especially because AMD cards work a bit differently than NVIDIA ones, because you can adjust your timings. So even if the chips might not clock super high, if they can do pretty good timings, you can still have decent performance, which is actually where this card might not be too bad. Because I've also been told that, you know, Elpida chips, they are pretty crap for frequency, but they usually do pretty good timings. So as far as timing modding the BIOS on this card goes, I can probably expect to run pretty good straps, even though the overall frequency of the memory on this is not gonna be great. Now, speaking actual numbers, in my testing, just everything at stock voltage, I have not done any overvolting test with this card yet. I got a memory clock of 1220, which seems to be pretty much average for Elpida chips. And it doesn't seem to be too bad. It's actually slightly above average for Elpida, it seems. Usually Elpida seems to stop at 1200. Now I got 20 more than that. But, like, I don't actually know what the Hynix chips do. Like, it's very possible that those do 1300. So, yeah, but yeah, it really depends. Like, if this card does good memory timing straps and frequency is not super trash compared to Hynix, or more like the performance is not super trash compared to Hynix, then I will probably keep the card and keep working with this one. If I do happen to think that the Elpida chips are a major issue, I will probably just keep buying 6850s until I get one with Hynix chips. Because, well, I could also maybe ask the seller, but I don't think many of them would be able to, like, throw the card into a system, open up GPUs, and tell me what chips it has. They're selling those for 15 euros. There's not really a lot of service that comes with that price. But yeah, so it is a bit unfortunate that I got Elpida chips. I wanted Hynix, but I didn't. Now I'm just gonna work with the Elpida chips and see how it goes, and then I'm gonna decide if I keep this card or if I'm gonna get another one and hope that one's better. As for core clocks on this, I got it to 905 megahertz, again stock voltage and stock heatsink. There doesn't seem to be anything special about that clock. I've heard that they are pretty easy to get to 1 gigahertz, but either the stock cooler is just not good enough for that, or my core is actually pretty bad. Or maybe those people were talking about overvolted cores. I've been told these don't scale that much with voltage, but I've also been told 260s don't scale that much with voltage, and in my opinion they do scale a lot with voltage, so, you know. Like, I'm doing testing after this video is done. Like, all the mods are ready to go. I'm just gonna test the card once the video is done. But yeah, like, I don't really know yet if the card has potential or not. So it's kind of hard to say. Now, if I want to go into the mods on this, like I've already said, this is just for voltage control and measurement. And it's my usual way of volt modding things. So I just have a massive terminal with these plugs on them. These plug into the Elmore Labs EBC, where I can then use them to monitor voltage and control voltage. So blue one is control for core. I don't actually have a measurement wire for core wired up right now because I'm using the one on the back, which is currently set up to hook into my oscilloscope to take scope shots. But I can also just use this for regular core measurement for the EBC. So I just, stick one of those cables into that and then I have core voltage. But then the rest is, so red is VDDCI, and green is memory. And yeah, like both of these VRMs are basically identical. They're single phase VRMs, very low end MOSFETs, as you can see by the packages, like these massive ones. They use the same controller. It's not a controller brand that I recognize, but if you just search for the marking on them, you immediately find the datasheet. And also, like, every single time I see these little 8-pin PWM controllers, the feedback pin is always pin 6. Every single time. On these ones too. I don't remember what they are, but just look up the part number, or just like, it's probably pin 6. It's never been another pin every time I checked. So, yeah. And that's literally just voltage control mods. I have not checked any voltage scaling yet. I'm gonna find out. Maybe I can get a bit more voltage, like a bit more memory clock from more voltage. I don't want to overvolt the VDDCI too much, because what I've heard about VDDCI is like you can very quickly kill the memory controller if you overvolt this too much. And the stock voltage is already like just below 1.2 volts. I think that should be high enough, actually. But I'm gonna do some extensive voltage scaling tests with the core and the memory. And then VDDCI, maybe I'm gonna let some other person like test with his card and see if they break it or not. But yeah, I think that would be mostly it for the video. Like, yeah, that's a quick look at the HD6850. And yeah, I'm just gonna do tests with this, like how it scales, how it behaves, so that I have about an idea of how the card, you know, works, how it acts, since this is the first time I'm working with an HD 6000 series card, the first time I'm working with a Terascale card. So I don't really know what to expect here. And then once the comp starts, I'm probably not gonna mod anything more than it is currently until the comp actually starts in like 2 weeks or so. And then I will, one thing that I want to do is like take a scope shot of the card every single time I add something to make the VRM perform better, like a cap mod, maybe load line or switching frequency mods. Or then in the end, when I do plan to do an e-power, I also want to do a scope shot of that. We just kind of see like, how's it affecting the VRM performance on this thing? Like, it's already pretty good compared to what I've seen on some NVIDIA cards. But I'm pretty sure it can be made better. So, yeah. And with that, I think the video is long enough and I've said everything. And so yeah, until next time, goodbye.